Welcome everybody to our third Bitfield lecture. What we're going to talk about today is some topics like this. We'll talk a little bit more about left shift and right shift, what they mean, what they do, what they're useful for. In your homework assignment, you have to get the highest bit out of a Bitfield. There's about 4 different ways I can think of doing that. We'll go over some of them. And we are going to talk about Modulus with powers of 2 using Bitfields, which is an incredibly useful technique that actually can make hash tables go much faster. Because, well, we'll get to that. But it's one of those things where, like, when you kind of understand things, then you can make code that is more efficient. And this is one of those cases. And you can get better performance on things that you might think you would get worse performance on. So we'll talk about that in a bit. Okay. So first thing up is right shift and left shift. So let's say that right now, this is our demo code from last time. We do have a left shift in here, but I'm going to show you kind of an interesting thing we could do with it. So what if we just said, like, enter the starting bit field here. And so, for example, if the user types in 21, it's going to say we're starting with the flamethrower, the bow, and the axe, because 16 plus 4 plus 1 is 21. Okay. And what I'd like to do is to print out which items I started with. And so let me show you this kind of cool for loop here. And then we'll do like a cout starting items. And what we're going to do is we're going to do this for loop here. So for int I equals 0, I is less than 32, I plus plus. The reason for this is because we have 32-bit integers on the server. If I wanted to be a little bit more precise here, I could say u int 32t, and or I could get the size of end there. Either way, that's all good. That's not the point of today. So what I want to do is individually test each one of those bits. So remember, we've got our three Bitfield operations: insert, search, and delete. And what I'd like to do is search basically for each of the items in the Bitfield. So say, like, do I have the axe? If so, print out we have item 0, axe. Do we have the sword? If so, print out we have item 1, the sword. And in reality, I'd want to have a function that would translate from a number to an actual string. That's kind of what I showed last time with the vim macros. By the way, when I see you guys not using macros when you're writing your code, I'm not saying who it was. I saw benediction yesterday. This is me when students don't use macros and type things a slow way. Okay. So I'm waiting for the response on that one. Yeah. So we can do this, like, print all of the items in the Bitfield. All right. And we can do so by left shifting the numbers. So if inventory bitwise anded with 1 left shifted I times, cout we have item I. Okay. So what's happening here is the first time through the loop, I is 0. If you left shift something 0 times, it's the same number, right? What happens if you move something 0 spaces? It's in the same spot. So if we take the number 1 and left shift it 0 times, it's 1. And so the first time through the loop, I is 0, so this number here is 1. And so we are bitwise anding inventory with 1. And so this is going to see if we have the axe. If so, then it's going to print out we have item 0, because this is item 0, item 1, item 2, item 3. And then the next time through the loop, I is 1. Now when you take 1 and you left shift it once, you get what? What happens if you have binary 1? What happens if you have binary 1 and you left shift it 1 time? What does it turn into? 2, correct. So if you have, let's say 0, 0, 0, 0, 0, 0, 0, 0, 1, and you left shift it one time, this turns into 1, 0. Okay, so the 1 moves to the left. All right, and so that's 2 in binary. And if we left shift it twice, then we get what? What number is that in decimal? 4. Good. So every time you left shift, you are multiplying by 2. All right. And so we're going to start with 1, and then it's going to turn into 2 in the next loop, then 4, then 8, 16, 32, 64. So it's going to check each one of the bits of that 32-bit unsigned integer we have here, our bitfield, and it'll just print out whichever trues and falses we have. Well, not the falses, it'll print out whatever trues we have. So if we run this, if we're starting bitfield is 21, remember that's 16, 4, and 1. So we have item 0, the axe, item 2, which is the bow, item 4, the flamethrower. Yep. Yeah. So we have the axe, the bow, and the flamethrower. And if you're writing this for realsies, you'd want to write a function that took the number and returned the string. Now, if you prefer thinking about it in terms of like powers of 2, remember order of operations here. Whenever you're using cout statements, always put parentheses around any of your bitfield operators, because order of operations, that's left shift. It's also the string extraction operator. So always be careful with that. So if you prefer getting the actual, like bit number 21 says we have item 1, the axe, item 4, the bow, item 16, the flamethrower. What do you guys think? You like that? And you can do this to find out what the highest bit is in the bit field. You have a bunch of 1s and 0s. You just keep go to the left, go to the left, go to the left, and you just kind of like write down. Every time you find a bigger number, you're like, okay, we that bit's the biggest number. And you go to the left, go to the left. Oh, I found a bigger one. That's the biggest number. You can keep doing that. And that will, that's a loop that you can use to just kind of go run down the whole thing and print out what you have and what you don't have. Seems handy? Yeah, I think it is. It's a pretty standard for loop. So, we could probably use a ternary operator. Let's do a ternary operator. Just for the fans of the ternary operator out in the audience right now, we're going to do that. So we are going to see out and then this we will do. Ternary it up in here. Okay, so let's do this. Okay. Okay. So the ternary operator, no, I did this to the earlier class as well. Let's see, we need the missing parentheses here. There we go. So this is like an if statement that's embedded inside of a cout. So it's going to say we, and then right here we have an if statement. And so it's going to say if bit, 5 is set or whatever, it'll print out we have it. If it's not set, we'll print out we don't have it. So this allows you to sort of embed an if statement inside of a cout. Because you can't just like type if here, right? Like you can't just like write if, whatever, like that doesn't work. Expressions can be put inside of a cout statement. Statements cannot. An expression is basically anything you can wrap a parentheses around. It's like 3 plus 4. You can put that inside of a statement. But you can't put a statement inside of another statement. Statements are things that kind of like end in a semicolon. If that makes sense. Okay, so if we do this, then we go through here, and it's going to print out 21. So we have item 1, 4, and 6. We don't have all the other ones. Cool. This one is negative because that is signed by default. So we need to make that a event 32t. And now we'll get the unsigned for this guy right here. Clean that up. Okay. So what other ways could we find the highest bit? Another way you can do it is you can keep right shifting and count how many times you right shift until it hits 0. So how does that work? So let's say we have like, let's just return 0 here. So we have like unsigned 32. Bob is equal to 32. We say Bob is equal to Bob right shifted 1 time. Cout Bob. What value is that going to print? Very good, very good. Now, if we have to, Megan, we can use a lambda to... I'm kidding. So yeah, if we right shift Bob 1 time, 32 is 32-bit, 16-bit, 8-bit, 4-bit, 2-bit, 1-bit. I know. Legitimately, I'm not trying to troll you. Okay, 0, 1, 0, 0, 0, 0. When you right shift it, the 32-bit becomes the 16-bit. And so it's like division by 2. Okay. So what if I had 33 here? So 33 would be this number in binary, right? So what happens when we right shift it? What happens to that 1 at the end? Does it wrap around? Does it fall off the edge of the world like Dio? Black Sabbath Dio? What happens? So what's it going to print? 16 still. Very, very good. Yep. So if we run this, we get 16. Okay. If we do 34, it'll print out 17. So right shift is integer division by 2. Okay. What if we right shifted it 3 times? That is division by what? Kitty! Kitty! The stray that's adopted us is outside my window right now. So 32 divided by what? 32 divided by what? When you right shift 3 times, that's division by what? So division, right shifted 1 time is division by 2. Right shifting 2 times is division by 4. Right shifting 3 times is division by 8. So it's 2 to the 3rd power. So if we divide that, Megan is correct, we get 4 as a result. All right. So you can use right shift for division for powers of 2. And you can also use bitwise operators to do modulus of powers of 2. But there's a little bit more in learning point 2 we can do here. So like right shifting twice. Yeah, sorry about that. I might have said twice. So if we are in a for loop, then what we can do is we keep right shifting until it hits 0. So if we do this, while true, Bob, count plus plus, count equals 0. Bob is equal to Bob divided by 2, while Bob. Okay, so we're going to keep dividing by 2 over and over again. And then when we're done, we can see out the count. So we're doing repeated division by 2. So you can see with 32, we had to do divisions 6 times. And that is, in fact, the highest bit in the number. So if we made this 32, we made it 37. This is the 32-bit, the 4-bit, and the 1-bit are set. We still get 6 as the answer. If we set this to 4, then it is the 3rd bit, right? 1's bit, 2's bit, 4's bit. The 3rd bit is the highest bit. If we set this to 7, the 4-bit, the 2-bit, and the 1-bit are all set, so the 3rd bit is still the highest number. So it's a repeated division by 2 to get the biggest number. Another way you can do this is by using the log 2 function. Log2 of Bob. And in this case, do we want to add one to it? Maybe seal, maybe. There you go, third bit. Make this 64. Sixth bit. 1, 2, 4, 8, 16. 1, 2, 4, 8, 16, 32, 64. So what's that? The seventh bit? Off by 1 error. Oh, it's because it's starting at 0. Right. Yeah. Right, because if we pass in 1 here, yes, this should be floor, not seal. And yeah, so 1 is the 0th bit because we're counting from 0. If we pass in 2, we get 1. We pass in 4, we get 2. Pass in 8, we get 3. So this is a very simple way of getting the index number of the highest bit. So that's 3 ways of doing it. We could do it this way. We can do it by right shifting a bunch of times. We can do repeated right shifts. We can do repeated left shifts. We can call log base 2. Or there's also if you know assembly, there's an assembly intrinsic available in C++ that will give you the highest bit of a integer. It's actually a Intel assembly command. There's 4 different ways of grabbing the highest bit. That is what you need for the weapon, select weapon thing in your Bitfield assignment. Cool. All right, now let's talk about modulus and division, maybe also. Powers of 2. So, int Bob is equal to read. We're going to read in a number, and we're going to see out what is Bob right shifted by 2. So if we right shift by 2, what kind of division is this? So we're going to read Bob in. Bob is 32. We right shift 32 twice, and we output the result. So this is division by Kitty. Division by Kitty. Division by 4. Good. All right. Now, what if we want the remainder? What if we want modulus by 4? Can we do that easily? I mean, we could always do this, right? But that's not fast. The modulus operator can take like 80 cycles to run if it's not optimized away. So what we can do instead is this. You guys understand what's going on there, or do you want me to go into more detail on that? By ANDing it with 00000000011, we're throwing away all the upper bits. All the bits above the 1's bit and the 2's bit are cleared. They're set to 0. And so all we are left with is whatever was in Bob in the 1's bit and the 2's bit. And so if Bob was 4, that's 0. Bob is here. Let me run it for you a few times. So if I type in 1, 1 divided by 4 is 0. I'm going to put in some text here. See how nice that macro was? Whenever you do vim, the last command is saved into an automatic macro. And then you just hit dot, the period key, and it will repeat the last thing. It's a lot better than typing it again. So if we type in 56, 56 divided by 4 is 14 with a remainder of 0. Type in 23, 23 divided by 4 is 5 with a remainder of 3. And all of this can be done in one cycle. Division and modulus can both be like 80 cycles. It really depends on the CPU. So instead of 160 cycles, a cycle is the time it takes for the clock to go high and the clock to go low. Instead of taking 160 cycles, we can do it in 2. Maybe less if we can combine these somehow. So let me show you why this is. Okay. So if we have the number 23, the number 23 is the 16's bit is set, the 8's bit is not set, the 4's bit is set, it's 20, 2's bit set, and the 1's bit set. Okay? And so if we AND it with 00011, which is this, if we AND them together, we remember when you do a bitwise AND, you're ANDing each pair of corresponding bits. So what is true ANDed with false? True ANDed with false. What is that? False. And then false ANDed with false. It's false. True ANDed with false. Press F in chat, please. Thank you. False. True ANDed with true. True. True ANDed with true. True. Okay. So when you AND something with 0, you just always get 0 as the result. Whenever you AND something with 1, you get whatever was above there as the result. So if we did this with, say, like 22, like this, then whatever numbers were above the ones there are what are going to be down here. And so 22 modulus 4 is 2. Yep. So we're just looking at the remainder of when you modulus something by 4, it's exactly the same thing as bitwise ANDing it with 00011. Okay. And this is an extremely fast thing. It only works with powers of 2. Like you can't do this for like modulus 11 or something. But for powers of 2, this can give you a massive speed boost. And so the fastest hash tables that I've seen implemented actually use powers of 2 in size for the hash tables. The reason being that makes the modulus go much, much faster. A lot of times the modulus to find the bucket in your hash table is actually the bottleneck. That's actually the slowest part of the process. The standard library hash table is actually quite a bit slower than the world's fastest hash tables. Like people have, done things that are basically compatible with a standard library hash table, but are like an order of magnitude faster. And hash tables are supposed to be the fastest, data structure for insert, search, and delete. That is correct. Yeah. So if you want to divide by 8, then and modulus by 8, you would right shift 3 bits, and you would keep the last 3 bits. So we're keeping the upper half here, and we're keeping the lower half down here, so to speak. Well, the upper 29 bits, and then the lower 3 bits. Yeah. See the upper 29 get shifted 3 times to do division by 8. Now, let's fix the comment. And then you mask off the last 3. The 1's bit, the 2's bit, the 4's bit. The highest it could be is 7. The lowest it could be is 0. It's modulus by 8. And this is extraordinarily fast. And this is not something that would like 56 is divided by 8 is 7. With a remainder is 0. 58 is divided by 8 is 7 with a remainder of 2. This is not something that would occur to most people, right? Like if you haven't had this college class, then like you would probably make your hash table like maybe prime number in size, which is very common. Double hashing requires you to have a hash table that is prime number in size. Double hashing is better than, like you can't use double hashing if you're using a power of 2 size. But power of 2 sizes are much faster to modulus. And so if you want the ultimate speed, you throw a ton of memory at the problem. You do a power of 2 size, and your moduluses take 1 cycle instead of 80 or 20. I think I looked at the assembly generated in the previous class. It worked out to about 25 cycles to do a modulus with the optimizer turned on. It's about 25 cycles to do a modulus. So this is a lot faster. And so, if your bottleneck is the modulus, which it often is, using a power of 2 allows you to do modulus like that. Kind of cool, right? This is why college is important. Speed matters. It does. Now, a lot of people think that computers are fast enough these days, but you always get to a point in your program where it's not running as fast as you want it to be. Now, if you're only adding up 10 numbers, if you're only storing in your hash table 50 elements, like, yeah, nobody cares. Sure. But for any system of any scale, of any size, if you're doing the DMV's database, and it takes 5 minutes to pull up somebody's record, then it needs to be fixed. Speed always matters. You always want the most speed that you can. The trouble is that a lot of people don't know where to go or what to do to get speed, and so they'll make these like weird optimizations, like I'll make this ++i instead of i++. It'll run a lot faster now. It won't. It'll make absolutely no difference. They'll do that, and then they won't turn on the optimizer, right? So, premature optimization is a sin, but when you understand things like this and why you can do a modulus so quickly with the power of 2, then that allows you to design a data structure that is much faster than that of the standard library. That's why college matters. Speaking of bitfields and bitwise operators, here in Fresno there is a organization called Bitwise Fresno, and has anyone here heard of them? Taking classes with them? They kind of do 3 different things. They do more, but they do at least 3 things. So, taking a few other classes, yeah. So first thing is they offer classes, so you can like learn how to do web dev and things like that. It's you can do like a 6-week boot camp with them, things like that. The only downside is like they'll encourage you to not go to college, and there's a reason why college is a 4-year process to get your computer science degree. Like there's just a lot to it, and in 6 weeks you're gonna get something. Like you're gonna get something in 6 weeks, but there's a reason why college takes 4 years to get a computer science degree. There's just a lot to computer science, and things like this, make a big difference in performance in the long run. So that's one thing they do. They have classes. Second thing they do is they have meetups. I don't know if they still do this, but they would have like pizza things on where it all started, Bitwise Fresno. Yeah. So they would do Friday meetups, and basically, if you're interested in getting a tech job, you go down there on Friday. They have pizza for free for everybody, and you eat pizza and you talk to people, and if they like you, they offer you a job, and boom, you're off to the races. So you never heard them discourage college? I had the ACM go down there for a visit, and they were like literally trying to get them to drop out of college, and like I invited them to my classroom to guest speak, and they were like, none of you guys need to be here. You can drop out and go to Bitwise instead. And so I was just like, bro, like really? Okay, man. All right, you do you. I'm all for them. In fact, like what I'm doing is, really the same goal that, Jake and Irma, the founders of Bitwise, are trying to do, which is like, when I came to Fresno, there was like no tech sector. And so I actually wanted to start teaching part-time. This whole tenured faculty thing is an accident. The whole reason why I wanted to teach part-time was because I really wanted to build a tech sector here in Fresno. I helped Fresno Pacific University start their software engineering program. And I've been all for Fresno trying to develop like a tech sector, because I grew up in San Diego and there's tech everywhere. And Bay Area, of course, is like the mecca for like all things high tech. And then, of course, LA, Sacramento, they've got these huge tech fields. Irvine is mammoth. But Fresno's like the 5th biggest city in California or whatever, and there's just like no big tech thing. And so the Bitwise people are trying to fix that, And so by doing meetups, like you can learn about the other tech people in Fresno. You can offer jobs and get a job. And We have farming, yeah. And wrestling cattle. Yeah. I like the story of bringing tech jobs to people. Yeah, and that's literally why I started teaching here. Was because, like, at Clovis Community College, they had Engineering 40. It's Seaside 40. That's it. They only offered a single computer science class at our college. And so I literally started teaching so that I could try to expand the amount of people that are, like, technology savvy, in Fresno. And then it just sort of, uh, I taught here for a semester, and then they're like, "How would you like to become a tenured professor?" I was like, I don't know. I'd make a lot more money not being a professor, but I kind of wanted to teach it. Like if they gave the job to somebody else, then I wouldn't be able to teach. So I decided I liked teaching more than I liked money, and have been doing this for a ways now. So yeah, the third thing that Bitwise does is they have like if you want to lease rooms and things like that. Like if you're a startup, you don't have to like go whole hog and like rent a building and things like that. You can actually go in there and like if you just want like a cubicle, they'll lease you a cubicle, and it has really high speed internet and like water coolers and things like that where you can like go and work in a quiet office with high speed internet. Whereas when you're at home trying to work and your kid doesn't respect, daddy's working right now, who's kind of wander in and do distractions. So the place there is like really nice for people that are like independent contractors that want to have like a place where you can go and officially be like working and things like that. So really, I think Bitwise is more of a real estate company now, because they're all about like buying old properties and renovating them and leasing them out and stuff like that. But I do like where their heart is at, and like I said, they have tech classes down there, and so you can learn from them if you're into it. All right, so that is basically our lecture for today. I'm going to hang out. Please work on the thing. The Bitwise homework is due on Friday. That's 2 days from now. So get going. I will be here and helping you. But I've noticed a lot of people just like kind of like just disconnect after lecture's over, and you're not taking advantage of being able to ask me for help. So ask me for help. It's good for you. Min Corelli and I were actually talking like next semester we might actually give a homework so hard that you will have to ask for help just to like prod students into like like get onto Discord, get used to not knowing everything, and I don't know. It might discourage. Yeah, it might discourage some people. So it might do something different. I don't know. Like maybe offer extra credit if you go into the tutorial center or something. Yeah, I don't know. Like we were just talking about this like after class today. Like how do we get students to like get into the habit of like, I'm stuck, I need to ask for help, rather than just like giving up or something like that. So maybe I don't know. If you guys have any ideas, let me know. Because it really is. Like in computer science, like everybody goes through periods of time where you're just like, I have no idea what's happening here. Like what? Like, I don't get this, and leaning on each other for support is kind of a very useful skill to get. He does that, you don't love it because you don't need help, you don't have the extra credit opportunity. No, it would be extra credit if you got a 0. So it would sort of set a floor on the assignment. So like if you got a 0, but you went to the tutorial center and you still failed, you get a 5. So basically trying to keep people from getting discouraged and dropping out if they failed the assignment. Yeah, it's basically kind of what we were thinking. But then for the students who got it right, 10 out of 10, no big deal. You don't have to go to the TC. So does that sound good to you guys? Maybe we'll do that for the last assignment in here. We got one more homework coming up, and we'll take a vote to see what kind of homework you guys want to do. So all right, so that's it. That's it for me. If you guys have any, you can place your votes now if you want. The two topics that I could teach on Friday are multi-threading, so parallel processing, being able to run on 2 different CPUs at the same time, or doing networking, so you can send data from one computer to another. So, or both. Maybe kind of some kind of puzzle of a nature that requires people to put their heads together. Yeah, that's good. That's good. All right, networking. You want networking? Okay. I'll start prepping a new homework song. A scale of 1 to 10. How difficult do you want it? 11. All right. You heard it here first, people. Easter eggs in each homework where you had to write a function that's discussed in class. You don't know which lecture. Yeah. Want to be chill. GitHub. Oh, yeah. We haven't done GitHub in this class. Yeah. Yeah, we're going to have to do some of the GitHub. Absolutely. I normally teach it. And have we done TDD in this class? Test-driven development. We might have to do something with that as well. Like G-test. Have we used the G-test framework? FizzBuzz TDD. Is that no? Okay, so those are both pretty crucial skills. So I'll put something together for you guys. I'll scale it to I don't know, a 6 maybe, something like that. It'll be a partnered assignment, and it should be good. All right. So you hate group projects? Well, I'll think about it.